Hello students, welcome back to OrganiChemVerse. In the last few videos, we have seen what is aldol reaction, aldol condensation, its mechanism, and how to write the product structure in one step. In this video, we are going to do something different. That means what? The structures of the products are given, then you need to find out what will be the structure of the reactant. This method is also called as retro method. For the given question, the IUPAC names of the product is given. You have to convert these names to the structures and then find out the reactant. Now, let's get started with A. The A product is 2-ethyl-3-hydroxyhexanal. So, hexanal means it is an aldehyde. So, preferably our reactant is also an aldehyde. Now, let's number it. The aldehyde is a principal functional group. So, when we number it like this, we can easily substitute the groups here. So, 2-ethyl. So, 2-ethyl at second position, there is a ethyl. And at third position, it's a hydroxy. So, you can see here, this is a beta hydroxy product, right? Now, in case of aldol reaction, we know that two aldehydes are reacting with each other and one will be an electrophile, the other one will be a nucleophile. The electrophile will be always converted to an alcohol. So, this part of the molecule is an electrophile. And we know that alpha carbon is the one which will attack the carbonyl. That means what? This is a carbon-carbon bond formed here, which we have to break here. That means what? This will convert to an aldehyde like this. Similarly, you see here 1, 2, 3, 4. There are 4 carbons and it is an aldehyde. So what aldehyde it is? It is a butanal molecule. So when butanal is treated with the base, right, we are going to get the product that is 2-ethyl-3-hydroxyhexanal. Now let's check for the product B. The IUPAC name of the product B is 4-hydroxy-4-methyl-2-pentanone. So it's a ketone. So the reactant will also be a ketone. Let's see what ketone it is. Pentanone, you write down 5 carbons and you see at the second position there is a ketone like this. So I would prefer numbering it this way. Now let's write the substituents. 4-methyl. 4-methyl is here and 4-hydroxy on the same carbon. Again, follow the rules. So this will be alpha, this will be the beta. So always you have to break the bond between alpha and beta. And you see this is a nucleophile, right? It is nothing but propanone. And what about here? When you break it, this is the one which is reduced to alcohol. That means that is the corresponding ketone. So what will be the reactant name? Propanone. Or the common name is acetone, right? So now let's check for the option C. What is it? 2,4-dicyclohexyl-3-hydroxybutanol. So always start from the suffix and the root word butanol. So butanol is like this, right? 4 carbons and an aldehyde. The reactant will be preferably an aldehyde. And now 3-hydroxy. At third position, we are going to write the hydroxy. And now 2,4-dicyclohexyl. So it has to be cyclohexyl here and at the fourth position also. Like this. Sorry, you have to extend it. Don't make this mistake, okay? So this you have to extend because 4, right? Like this. Don't write it over there. It has to be a substituent like this, okay? As I told earlier, identify alpha, beta, break the bond over here. Now, let's see here. This is the CH2. And what about here? This is the aldehyde because this is also an aldehyde. You either start from this molecule or this molecule. Anyway, you are going to end up with the same reactant because it's a self-condensation. That means it's going to react with its own type of molecule. Now, let's check for option D. What is it? 5-ethyl 5-hydroxy 4-methyl 3-heptanone. So first you write down the structure of heptanone. Heptanone will have how many carbons? 7 carbons. So 1, 2, 3, 4, 5, 6, 7. And at third position, 1, 2, 3, there is a ketone, 3-heptanone. And at fourth position, there is a methyl. And at fifth position, there is a hydroxyl and also an ethyl group like this. Now this is alpha, this is beta, beta hydroxy. Break this. Now check for this 1, 2, 3, 4, 5 like this. And how many times? 2 times of the reactants. Once you know how to predict the structures of the reactants for the given products for the aldol addition reaction, it would be easier for you to predict the structures of the reactants of the aldol condensation products. The first aldol condensation product given here is, it's a ketone because the name is butenone. That means it is a ketone. Let's convert the IUPAC name to the structure, then it would be easier. So since there are 4 carbons, let's write down those 4 carbons like this. And I would like to number them because it will be easy to substitute the groups given here, right? So now, at first position itself, there is a ketone like this, right? And at first position, there is a phenyl also. So for phenyl, you have to extend it and then write the phenyl. Phenyl means C6H5 group, right? So this is the phenyl group. And also at third position, you see there is a phenyl group like this, right? And then but2-ene, that means there is a double bond over here, right? 1 on. So now this is the structure of the product. Identify the alpha beta unsaturated carbons. And then you have to cleave the alpha beta, right? Like this. And then you have to write wherever there is a carbon-carbon double bond, there you have to write carbon-oxygen double bond. And then there is a methyl group as it is, like this. Since it is a self-condensation, that means these molecules, there are 2 of them. How so? Look at this, phenyl COCH3. This is how you will predict the structure of the reactant. Let's see the next molecule, which is also known as mesithyl oxide. So how to convert the name to the structure? So start from the root word and the suffix. There are 5 carbons, 1, 2, 3, 4, 5, and then I'll number it, okay? It would be easier this way. You can number it either way, all right? Now, at second position, there is a on, right? And at third position, there is a double bond pentene. And at fourth position, there is a methyl, 4-methyl. So 4-methyl pent 3 in and 2 on. So this is the structure. And as I told earlier, identify the alpha beta, cleave the bond. So you see here, what do you get? You're going to get the acetone. How so? You just break this bond and replace it with the oxygen, or you simply break this and write the 2 hydrogen, nothing but it is a acetone or propanone molecule. And what is the reactant in the first case? It is called as acetophenone molecule, right? So let's check for the C. This is called as 4-one. So what is the structure of the 4-on? Let's see that. Heptadiene 4-on. So no problem. We'll write down 7 carbons. Why so? Because hepta, right? So 1, 2, 3, 4, 5, 6, 7. And where do we have the on? It is on the 4th position. So you can write down the on here, right? And where are the double bonds? At 2nd and 5th position. Since you are getting 2 double bonds, right? Like this, 2 and 5, you can write here, and 2 comma 6, 2 comma 6 like this. As I was telling earlier, since you are getting 2 double bonds, you have to cleave both of them. That means what? You see here CH3CO CH3 like this, or you write down hydrogens here and here. That means nothing but acetone or propanone, same here also. I hope I made this concept clear to you, and if you still have any questions, you can comment them in the comment section. Thank you for watching this video.